I think we can begin now, Sergio, if that works for you.
Okay, yeah, let's get started then. Morning, everyone, and welcome to this webinar. We're going to try to talk today about the challenges of using Kubernetes on a secure environment like financial institutions. Nigel, you want to introduce yourself first, and then I'll pick it from there.
Perfect. So my name's Nigel Douglas. I've worked at Tigera originally as a solutions architect. So I work with customers who are trying to solve real world problems. Maybe they're already using our open source project Calico and are looking to gain some enterprise capabilities, which we'd offer in Calico Enterprise and Calico Cloud. I now work as a partnership product marketing manager. So working closely with the likes of Sergio in order to to work with their clientele and just understand what problems they're facing and if we can help with those problems.
Thank you. So for my part, my name is Sergio Rua. I work for a company called Demilitarized. I'm a principal DevOps. I look after different customers, and many of them are in the financial sector. I come in from a background as a contractor before, so I worked for many different companies. Many of them were banks and financial institutions, and that's why we thought that my experience was relevant for this presentation, and I hope you enjoy it. So let's get started. So a bit about Demilitarized first, if you don't mind. So Demilitarized is a consultancy company. We help companies adapt Kubernetes, be it on cloud or on premises, amongst many other applications. We focus on data a lot, things like Postgres databases, Cassandra databases, things like that. And we are very DevOps orientated as well. So we spend a lot of time making sure that everything's automated, and we can deal with pretty much anything from a hands-off environment. We don't like getting to servers and do things manually. So we do help DevOps teams to adopt practices to ensure that everything is working, it's zero downtimes, and if they need our help, we are 24/7 available for them to do it. We also provide managed services. So if you prefer as a company not to deal with the hassles of running a Cassandra cluster or a Postgres cluster or whichever your application you're trying to do, we can do it for you. Things we're asked a lot lately, it's about Kafka, and we've got quite a few Kafka experts in the company. We spent a lot of time looking into Kafka and Kafka Connect clusters. Also a lot of for the financial institutions, we do a lot of CDC Kafka processing. Many other things we can do, just pretty much anything you need, we can help with, from thing augmentation, documentation, training, whatever you need us to do, get in touch, and we should be able to help. Right, well, let's get started from the very beginning of the time. In the very beginning, we had a schema that was working for us. We called it the DM set, and DM set was a security environment. So we had tier separation. We had the less secure applications in the outside and the more important applications in the inside, with the firewalls in between all the tiers. And also we had change control. So every time we did a change to the network, we had to go through a set of processes to get it approved and deployed. I remember from my days working on data centers, for instance, I had to take some time designing a network, racking the servers, putting them into the network, then getting with all the paperwork to get it approved by change control, having to do a presentation for all change control board, and a lot of processes to get everything up and running and working. And that seems to work for us because for the most part, networks stay secured. There are cases where does not what happens, but in general, the tier separation, the firewalls worked as from a security point of view. But then we go back into modern times, and something new comes along, something that is pleasant, but also brings some challenges, and that was Kubernetes. How things changed is, if you look into this diagram on the left side, we have the traditional networks definition with 3 tier separations. So the bottom tier database, your most secured part of the network, means you can see your user has to traverse 3 different firewalls to get into databases, going by the web server, the application tier, and then the databases. But if you look into the right, this is what we have now with Kubernetes. We've got everything residing together. Everything is one next to the other. There is no separations, there's no tiers. It means that a database has the same level of security as a web server. And that obviously is not the way to do it, because there's gonna be some issues with that. How can you actually put your web servers together with databases? Can you actually guarantee that your database is going to be secure when you're exposing them to the outside? Most likely not. And that's what happens when you don't. You're starting to get some security issues and compromises. And you only have to look into Google a little bit, and you'll find that this is very, very common. It happens more often than we want to. But for us in institutions, there is a second part that perhaps is even more important than the security itself, because it risks you being able to operate as a bank or as a financial institution, and that is regulatory compliance. The companies that they work with customer data, they get scrutinized quite a lot, but companies working with security data and financial data, they have to go through a lot of hoops to get approvals and be running. On this list I just put together, perhaps you all heard about the PCI DSS, which is the most important of them all, but there are quite a few more. And when I was researching for this presentation, I noticed the European Union is coming up with their own version. They call it the European Cyber Resilience Act. And if GDPR is by any means of significance to how they're going to do it, it's going to be a blast for all of us to get to deal with cyber resilience. And we're going to have a lot of this, a lot of scrutiny, a lot of explanations to do. And what the companies I work with is actually right now going through all the scrutiny that they've been checked inside out for the security measures, and they're not having a great time, to be honest. Excuse me. The data breaches on the financial sector, they're quite important, and they can be quite costly. It's not just the amount of the data you may lose, it's actually all the fines you're gonna get from the regulators for not doing your work properly. Something that is often forgotten as well is many of the data compromises. The exposure of data is actually internal more often than not. I remember working for a company quite a few years ago, and they had several hack attempts from the call center from the company, and the call center had a churn of people quite high, so they're getting new hires every other week, and some of those guys, they just didn't have anything better to do than to try to compromise the networking, leak some data. So as we go from traditional networks into cloud computing, it gets even more difficult to do sometimes because the cloud computing it's more dynamic. So some of the good lessons we learned from deploying physical servers and deploying physical networks kind of got lost in the mist. And then we all want to make things faster and quicker and get the servers up and running with no hassle, but then we forget about the security part of it. I found this chart quite interesting in a couple of ways. As you notice, on the right hand side, the top of the list is the broken access control, and that used to be in the middle of the list. And same for the insufficient logging and monitoring is also going up a little bit. And when I was looking into it, it kind of explains to me why this happens, because we sort of forgotten the good practices of getting everything secured through traditional firewalls, getting logging, getting access control. On cloud environments, more so on Kubernetes, this is not often the case. Everything just gets put together and everyone gets access. And no wonder that the risks are increasing drastically. Kubernetes offers quite a few challenges. Things that Kubernetes is clearly not designed for security. And that's why we need products like Calico to help us with that, because the security is actually quite different in many ways. We're still talking about firewalls, we're talking about security rules, we're talking about access controls, boundaries, but it's very different when you put everything together in one place. If you think about in the olden days, I call them the olden days, the VM or the physical server was actually the most smallest part of your network, your granular component. That was your security reside. It had a IP address, and that was your access control was all based on IP addresses. But then when you move into cloud native applications, everything becomes dynamic. So you no longer look into the IP addresses and the network segmentation, you look into labels, and you look into these applications is next to these web applications next to the database. How do you control access from one to the other without network separation anymore? And the other thing that happens a lot is that we change practices. So I've been in the industry for a long time, and I have experience in pretty much any. I've been a DBA, I've been a network specialist. I've got my Cisco CCNP. I understand networks, I understand firewalls, I understand how security works. I know how to implement policies and how to implement best practices. But then you get into the DevOps practices when everything is dynamic, everything is about deploying quicker, using Terraform, Ansible, Chef, Puppet. And those good practices, they're not used anymore. People don't even understand firewalls. I had not that long ago a DevOps guy asking me what a gateway was for. I just couldn't believe that someone was asking me that question. But then again, it's a brand new world. So if you think about Kubernetes, you don't use a gateway for anything. You don't use IP addresses for anything. Everything is about your pods. So those good practices are lost in many ways, and we need to bring them back if you want to continue with the security. Getting to a bit of the explain a bit how the network works in Kubernetes. Is that you basically have no longer a predefined ingress and egress. You don't have the IP address to deal with. Everything it's a very large network. Everything is together, you no longer have access to things like logs. Everything has to be configured anew. You can't see the firewall rules. You can't see the policies. It's very difficult to get alerted when something goes, when you got a threat in your network. It's quite difficult to get an alert for it, because the firewalls on Kubernetes are no longer based on what we learned over the years about this is my /24 network, and I'm going to allow access from the network where my database is kept into the application tier. You don't use that anymore. Now everything is about a label. So you label your applications with this is my database tier, and you give a label to it. This is my application tier. You give a label to it, and then you work with labels, no longer with IP addresses. The source and destination is dynamic as well. Remember, the pods are very short-lived, so you have pods being created and destroyed sometimes every few seconds, and every single time they will get a brand new IP address as part of the very large networks. Often Kubernetes uses as well 16 networks, which are pretty large. So you cannot no longer use your IP addresses for securing your applications. You have to do something else. And that's why you have to segment your network based on labels and policy, and your policies become something different. And you can still create network sets. Sometimes you still gonna have some IP addresses, especially when you do not everything you do is in Kubernetes. For instance, quite often you get your database outside of Kubernetes, perhaps running on AWS RDS. And in that case, you may have a few IP addresses to deal with. And then you can create network sets and then say, okay, my application can actually get your database because it's outside the network, and it can use those IP addresses to connect to. Yeah, so I was just perhaps repeating a bit. So everything becomes dynamic. Your network is flat and large. Your pods, the containers, are the smallest part of your network anymore. No longer are the VMs. Now is the pod. There's no routable traffic between pods. Everything, because it's in a flat network, obviously, so that you cannot control the access that in the same way as before. And everything is abstracted into labels. So you use labels to identify source and destination traffic. So in essence, you're going from this traditional firewalls into something a bit more dynamic like this. The network policies, as you can see in this diagram, see the label it uses. So in this case, it matches the label front end to the database. So meaning that the database can only be accessed from the front end and only on that port 6379. So it's slightly different definition. You can see that there's no IP addresses anymore. It's just labels. As I was saying, it's actually possible to use IP addresses, and use cases for IP addresses most of the time are for the egress and not for the ingress. When you, as I was saying before, when you're trying to get access into something that's external to your Kubernetes cluster, like a database or something like that, as opposed to the incoming, because the ingress is going to be really difficult with dynamic IP addresses. And from there, you can then start looking into, yet again, build a 3-tier separations, at least. So when you protect your front end from the database and from your middle tier by using labels and selectors. And the positives to it is like, before, imagine you had 100 VMs, you had to create 100 firewall entries for your VMs to protect them all. Whereas in here, you can group them by labels. So you'll just need a single policy to protect all your pods from the middle tier or all your pods from the database tier. And jumping tiers when you do the policies properly is no longer allowed. So you construct your firewalls from the premises that everything is denied by default, and you open only up wherever is required from your pods. There are many challenges to deal with in still the network. The zones, because the way they're defined and the large network, you have very limited visibility. You deal with very large IP ranges, like we were saying before, often using /16 networks. Everything can talk to everything. So connectivity between tiers it's by default non-existent. I meant by the opposite. I mean the tiers mean nothing because everything can connect to everything. And yeah, and you got the large IP ranges on your pods and services network. So you start building a traditional firewall, but using zones and labels. It doesn't mean that everything is going to be perfect. You still need to put on some controls. One of the risks of using label selectors is that if a person has permission to change labels, for instance, on a pod, it can very easily bypass the network because it will basically change the rules of the game and grant itself access. So when talking about security, remember the security to Kubernetes cluster is even more important than your network. So be careful with both. Question I've been asked often is when people look at the Calico enterprise products or Calico cloud products, they think I don't actually want to use a web UI. I want to do automation. I want to put my rules into my pipelines and want to deploy them automatically. Yeah, the fact that they use a UI, it does not mean at all that you cannot do everything from the command line and you cannot integrate with your DevOps pipelines. Everything is a resource definition, standard Kubernetes resource definition, and you can just copy and paste and put into your pipelines and apply the rules from there. Be it you use Helm charts or whatever you're going to use, yes, no problem, you can integrate your policies with them. And that will give you the best of both worlds because you can do Kubernetes deployments on a DevOps style way faster than we used to do for VMs. Setting up a VM, for instance, or a physical server, it takes quite a long time just to provision the server and run your automation, Ansible, or whatever you use, secure the server as a whole. It takes a long time to do it, even if you use containers. Whereas deploying to Kubernetes, because just your granular part, your smallest part is your container, there's not a lot to deal with. So you can really speed up processes a lot by deploying into Kubernetes. Case scenario we work with often, it's the financial sector is adopting Kafka a lot now. All the CDC processes are going to Kafka, Kafka and Kafka Connect. So we see very often companies asking us to help with providing a CDC between the database and whichever the sink is. Example like this in the screen with your you're sourcing from a database, you're processing some records, and then you put those records into somewhere else, Elastic, another database, or Redis. So you need to protect all of this. By default, in Kubernetes, remember, your database will be in direct contact with Kafka and in direct contact with your sinks. There will be no boundaries. There will be nothing. There will nothing that prevents the databases to be read from somewhere else in the network. That's why you start to build policies and tiers, like we talked before. So you create your DMZ again using, you notice then the screen, everything using selectors. So just to explain a little bit what this policy looks means, just you've never seen it before. On the, you look in line number 9, you see a selector for FW zone DMZ, where it means that it was going to look up for any pods labeled as FW zone DMZ and apply to those pods all the ingress and egress rules defined in there, meaning that only, for instance, the type public will be able to connect to them, to the DMZ, and only the trusted and logging are going to be able to go outside of the DMZ. Then you build your second tier, you trusted zone. You can see the order. So I forgot to mention that on line number 8, you can see the order, because you can order policies. So you remember the first match is the one that counts. So when you order the policies, you can be more strict as the numbering increases until you get to the point where everything is denied. And finally, you get your less restricted. So the more restricted network as well, would you protect everything? So you only get access from all the from the other tiers. So only the trusted and restricted will be able to access these more restricted areas. Another thing that often I ask about is the many companies, large companies, financial sector, banks, they don't allow egress connections. They don't allow anyone to get to the internet unless they go through a proxy. And they were asking me, how did you do that on Kubernetes? Well, there are multiple ways of doing it, but when you use things like Calico Enterprise, you can implement global policies, and you can use those global policies to restrict access to everything, and then tell the applications to get to the internet via a specific proxy or any other connection. And this is quite important because as you can see, for instance, from Capital One data breach, if you don't restrict your egress, you can very easily someone just post or just copy the database and post it to the internet. Like in this case, someone did to GitHub, which is quite astonishing. This is what a global policy looks like. The global policies, as they apply to the Kubernetes cluster as a whole, as opposed to individual namespace like the individual policies before. This gives you the ability, like I was explaining before, to block, for instance, all your egress to everywhere, and then just grant access to certain applications only. You can see that on this policy, everything is denied by default, and then you get some global policies to allow access to specific sections, like to logging into Twilio and some other network areas where you allow your containers to talk to. When it comes to logging and monitoring, this is Kubernetes is very limited in the way that it can monitor the network. It's really difficult to get. You can get the logs relatively easy from Kubernetes into somewhere else. You can install sidecars and connectors to get your data out from Kubernetes into Elasticsearch and Datadog, or whichever application you use. So you can get the logs relatively easy, but it's far more difficult to get your application security logs. So events like firewall events and security events, that means that you've been compromised, or that you've got some security issues to deal with. if you have access to the Kubernetes nodes, you may be able to put something in place and check the log files. But if you don't, for instance, if you use AWS or Google Kubernetes, where you don't have access to the worker nodes, it's far more difficult to get anything out of them. So this is where Calico will help you a lot to get all your data from data logs out and be able to see them. You can create specific policies to enable logging. And so for instance, this example in here is gonna log all the pods with the level front end, and any action they do, any ingress is gonna be logged. And if you got a denied, you're gonna be able to see where it's been denied and why it's been denied. And you also get a good visualization of the full network itself. And you can see where your choke points are and where your security needs to be tightened up, or perhaps where your traffic is being denied and something you need to address because your application is not working anymore. And something you can finally see that all the different issues, you can spot them much quicker than with traditional Kubernetes. If you ever worked with network policies before on Kubernetes, you'll find how frustrating it is to get a policy that's not working, and then suddenly your traffic is blocked and you've got no way of finding out why it's been blocked. I've been there many times, but since we use Calico, just as simple as going to the UI, check on the logs, and you can see very quickly what your traffic is being denied and why it's not working the application. It saves a huge amount of time and resources to get things working. Another important part for financial sector, for everyone, but especially for financial sectors, is the encryption. You can look into things like a fully meshed network with Istio or Linkerd with MTLS that we use on pretty good encryption, but those are really difficult to set up, and not everyone wants to use fully mesh networks. I particularly don't personally like Istio. I think it's way too complex. But you can do encryption with Calico, and with Calico it's actually very simple. It's just literally enabling a switch saying encrypt, and you get all your traffic between nodes encrypted. It works very well. Going forward, you need to be able to also control who is accessing your Kubernetes cluster and who's doing what. Something I see often, and when I say often, I say nearly everywhere, is that some companies spend time securing their network, securing their pods, creating network policies, preventing your database to talk to the front end and things like that, which is all well and good. But then everyone has access to Kubernetes. So I've seen many times when people say, DevOps people said, oh, actually, this is not working for me because the firewall's been blocked. Okay, I'm just going to change the firewall and network policy. It's going to allow access. So you need to know who's been messing around with your firewalls. You need to know who's been changing what you shouldn't be changing. You need to get some access control. You need to make sure that people don't have access to change your policies, don't have full access to Kubernetes if they don't need to. You need to separate your teams as well. So you don't need a tester with full access to Kubernetes. You probably don't need a DevOps either. Full access to Kubernetes, you need some role separation, proper RBAC. And you need also to make sure the passwords and the authentication is centralized, and you can connect to the cluster from a well-known well-known security provider. Calico supports many identity providers. You can probably integrate with your company once, like most companies will probably use Google or Google Cloud, or so Google Workspaces, Active Directory, LDAP, any of those. You can integrate with any of them. And then suddenly you get a view as to who's being logged into Kubernetes and policies, and who's been changing policies, and who's been messing around with things that shouldn't be touching. And then you can create RBAC authorization, and you can split roles, and you can get some people with only view access, and some people with being able to edit changes, and some others to do nothing and don't logging out at all. And then suddenly everything is easier to identify when something goes wrong. You can also review the changes. This is a nice feature that you can review the changes before they get applied. And you can see who's been doing what and why. So if your firewall, so your application suddenly stopped working, you can go into the history and find out, oh, actually, yes, because someone made a typo, and that's why it's not working anymore. And you can also see who's been doing what. You can see who's been logging to Calico, who's been changing policies, and find a culprit, someone to blame. For financial sector, the listen, one of the most important parts, but also someone that not many people want to deal with, is compliance. But unfortunately, being such a regulated sector, compliance is very important. Compliance needs to be dealt with. So that's where you can use the compliance reports and so other features on Calico Enterprise and Calico Cloud to ensure that you're getting the best out of your security. For instance, this example in here is a screenshot. You can see the CIH benchmark, which is the industry standard for to seeing how secured your servers are. This is the benchmark for Kubernetes. So this is something that security teams use all over to just confirm that they are compliant with all the security and best practices. And you can create multiple compliance reports. You can create your own. You can even get alerted when something is out of compliance. And you can really find a good way of getting your network, your applications and your network protected and compliant. I'm coming to the end of the presentation. I think we can probably stop in here and ask Nigel to show us a bit of a demo of the Calico Enterprise to make those things stick. And then we'll come to the end for the questions and answers for anyone that wants to see more. Nigel, you okay with that?
Perfect, yeah. So if you stop sharing, I think I should be able to, perfect, start sharing my screen. So yeah, everyone should see my terminal at the moment. Now I've set up a few scripts in advance, but here is the UI. So what we're going to do is we're going to enforce that shift left idea of security coming before DevOps and product pipeline development. So to build anything, we can do it via YAML manifest, but right now I'm building it simply via web user interface. So I can say, I'm going to call my tier Tigera Security, because we're going to get the security done by policy provided by Tigera. Now I can say insert it after a tier that already exists, and then we have our tier. So the tier is this logical abstraction layer where we can actually put policies into tiers. Historically, what would happen is there's no concept of tiering in any open source policy framework. So whether you use Calico open source for policy or using a Kubernetes policy framework, you wouldn't have this concept of tiering. You would simply have order numbers to design where policy should fit in. So in this scenario, I can build these tiers. I'm going to build a second tier so that it comes again after security, so that the idea being is policies are read from top to bottom, left to right. So there's an order of precedence here. And again, it's enforcing this idea that security should always come first. So the first script I'm going to run here is I want to put a policy into product. And we want to recreate that same security model we're familiar with that DMZ, that zone-based architecture is what I should be saying. So if I go to VI on my dmz.yaml file, you can see this idea where I'm saying any workload with this label ID of FW zone equals DMZ, then allow that traffic from public internet range. So you can see from a public IP CIDR range of 18.0.0.0/16, and that's for ingress. So any incoming traffic, like Sergio said earlier, I can make a kind of a broad rule from an IP set because I don't know the identity of those external, feeds. I'm just saying public traffic, allow it into the DMZ. Naturally, any other traffic that isn't from that CIDR range, I'm going to deny it, and that includes internal traffic. And then from an egress, what I'm going to allow out of the DMZ. So if what we saw earlier from Sergio's presentation is you would have the DMZ to handle essentially public traffic, funnel it into a trusted zone. So you can see I'm allowing egress to a trusted zone or anything that has app equals logging. And then anything that isn't those zones that I approve of based on this label schema, I'm naturally going to deny it. So that's the second action I'm defining here. So with that, I can quit this file. I can say kubectl apply-f on the file, which is dmz.yaml. And within milliseconds, that will show up inside my UI. Now, okay, so it's not going to create yet because I don't have the application storefront. So what I want to say is kubectl apply-f storefront. And now I have my test application is being created. So it's identity aware policy. So of course you have to have the application in place, the namespace has to match the context, and then the policy will be satisfied. So in this case, if I say apply-dmz, you can now see it creates the DMZ policy into the product here. And like I said, in next to real time, it shows up inside this web user interface. So we're communicating the whole time via an API server. That works the same, that Kube API is going to work the same if we're doing this through the web UI, if we're doing it via the CLI, or if we're trying to do it via automated CI/CD pipeline. So in this scenario, you can see there's already an issue. So what I'm doing is you can see, although I'm trying to create this, good security posture, I'm actually denying egress traffic out. And when you think about it within Kubernetes, all workloads need to talk to the Kube API, or sorry, I should say to the DNS, core DNS. So I'm allowing pods only talk to each other, but I forgot core DNS, and all the workloads need to communicate with that service. Now, since we have all this observability capabilities in the solution, we can easily see in any specific service graph or flow visualization that I can drill into a network set, let's say storefront, the application we're focusing on now, I can see the pods that are running within it, but I can see that there is denied traffic. This is this red line, and that's the traffic going between that front end workload that had the label of, FW zone equals DMZ, and it was going to kube system, which is essentially the core DNS workload that was denied. Now you can filter and show additional data here. So what we're doing is the graph, you notice it automatically got populated as soon as I introduced the application. The reason for it is we're handling all that flow data, Sergio said, and then we aggregate in a way that populates this graph. So that's really, really nice. If I click on a test application and I open up this left side panel, you can see that when I click into that specific line, it's talking here, and the egress that was denying the traffic was in fact that DMZ policy in that zone. We have all the additional context to whitelist that traffic. Now, to speed up the process, what I've already done is I have a policy for it. So if I say kubectl apply-f, it's going to be allow kubedns. And like I say, when you apply policy, it's going to show up in Tigera security tier. And inside the UI, when I go back here, I'm whitelisting the traffic here on allow kubedns. If I view the statistics, say the allowed and denied traffic, as traffic starts getting allowed for, again, I'm making a broad rule here. I'm actually whitelisting pretty much all traffic on port 53. So the expected UDP traffic that would go to kubedns, I'm whitelisting that at an earlier stage. Only, again, it's a global rule, so it applies to everything, but I'm only sending it to anything that has K8's app equals kubedns, which is definitely core DNS. But when I go back to the policy board, you'll see the amount of denied traffic will go away. So we're able to see what's happening. This is good for troubleshooting, but it's also you can see I'm doing this secure way. I'm not just whitelisting UDP for the whole cluster, because that would be an incredibly insecure thing to do. Certainly wouldn't meet compliance. So we're saying once we are aware of the identity of what we want to allow based on label, then I can securely allow that traffic. So now that the DMZ works perfect, there's a little bit of denied packet still there, but I think that's going to dip off in a second. I'm going to go ahead and finish off my zone-based architecture. So with that, I can say kubectl apply -f the trusted zone. And again, once you apply it, the policy shows up inside the UI. And then I want to create the restricted zone. So kubectl apply -f restricted. Now, as I say, whether you read this in the CLI or in the UI, you can easily see, again, in humanly readable format in the UI, it's saying anything with this label schema in this network namespace, then apply the following actions on it to allow traffic based on, again, it's identity aware based on labels. So if I was to kill a workload, let's say if I go into my pods, so we say kubectl get pods -n storefront, that's the test application we're looking at right now. All those pods have their own internal IP, so -o wide. You could kill a pod, so you could say kubectl delete pod. So in this case, I want to delete the pod, let's say backend, this database. Since Kubernetes is self-healing, when I kill that pod in the network namespace storefront, the controllers should attempt to recreate that pod. So as I get pods -o wide, you can see now a new backend pod's running. It has a new IP, so it ends in .28, where previously it was .26. So Kubernetes, or I should say Calico, is reassigning that IP via our IPAM plugin. So you wouldn't build policy based on IP. Like we say, it's short-lived. Pods die the whole time due to scaling up, scaling down. It's the whole purpose of an orchestrator. So as those natural things are happening, IPs are reassigning. We're not building policy on IP. We're doing it all based on this label selection. So when we define those pods, let's say we run that policy again, instead of -o wide, I say --show -labels. I have a clear label schema to say anything in the back end, the database, it's in this restricted zone. Anything in the front end that would talk to the public internet has this firewall zone of DMZ. And then anything in the middle that relays the traffic from the DMZ to the backend are in a trusted zone. So I know there's two pods that have that context. So yeah, if we go back into our view, we can actually see for sure that we know the number of endpoints that are in each zone. So if I clicked into trusted, I know that there are the two microservices. So we're maintaining that compliance. We're locking them down, enforcing zero trust. But to meet PCI compliance, there's a lot more than just microsegmentation. You need to show to an auditor that it's being enforced. A great way to do this is, let's say I create a default deny inside that network namespace, like say default deny storefront. Now, if you've never seen this before, you can basically say after these policies, make a namespace scope policy for the namespace storefront. And if I was to enable the actions of ingress and egress, so I'm basically saying on any pod in this network namespace, enable ingress and egress, but don't define an action for it, Kubernetes doesn't know how to handle those packets and it will drop them. So if I was to enforce this policy, as I said, I enforced it after the others, so they're read from top to bottom. Anything that wasn't already enforced via microsegmentation, the traffic I do want to allow, should get dropped by this policy at the bottom of the tier. So I can logically show, aside from having the security posture, which is good, I can show the auditor that I am actually enforcing a best practice structure, and any new unwanted workload would get denied. Now, this is worrying because I'm seeing default deny actually dropping packets, and I thought I already created my zone-based architecture. So that's why the label scheme is so important. When we go into these graphs, we can see where that denied traffic is coming from, so we're going to. So if I was to choose the network namespace storefront and look at all the pods in it, or in fact, if I just zoomed in on the network namespace, you can see there's a lot of denied traffic. In the past, there was between front end and kubedns. I think I whitelisted that, but now we're looking at the last 15 minutes. So maybe if I looked at the more recent data, I would see that in this network namespace, it shouldn't be an issue with the namespace kubedns. Instead, there should be some new denied traffic coming through. And it's, okay, that's between the microservice and public internet. I don't think that's their issue. We'll come to that one in a while. But I think it should be coming from logging. And the reason for it is you can see backends denied traffic to logging in the last 5 minutes. and front end deny to logging. Some traffic says green, but that's only because in the last 5 minutes, we didn't have this default deny enforced. So you can see in the case of that denied traffic, you can see it's actually denied by this policy, default deny. So what happened was the logging component, when we go back into the UI, we can see it does have this label of app equals logging, but it's not considered into our zone-based architecture, this firewall zone equals whatever. So as a result, because I didn't encourage it or didn't kind of design a label schema that involved logging, those packets are getting denied by default deny. So what you can do with this web UI and all this lovely, features to show you that packets are actually being dropped in production, I can go back into my policy board. There's actually a feature called recommend policy. And from that, I can just look over the last 15 minutes of log data or longer. I could look at hours, honestly. But if I was to look inside the namespace storefront and choose the broken component, which is logging, and click on recommend, what it does is, you just saw that was in milliseconds. It's saying from the traffic we've aggregated and seen, we know the pod has this label of app equals logging, as we saw there. So it's a static construct. It's not going to change. It has that label. And I know over the last 15 minutes, it has been only receiving ingress because we know it's a logging component. Logs don't, it's a log aggregator, should only receive log events. So it's receiving TCP 8080 traffic from these workloads. And you can see that zero trust here. So although it suggested a fix to our problem, it's also fixing the problem in a way that's most secure. It's not just whitelisting traffic between pods, because if a pod was compromised, it could talk over any port and protocol. Instead, it's only allowing the port and protocol we've currently seen, just the expected traffic. So with that, I can click on stage. So this beautiful idea of staging policy to see what effect it would have in an environment without actually enforcing it. If I go back to my policy board and scroll to the bottom, you can see here's the gray staged policy. I can drag and move policy wherever I want. So I can make sure it's before the default deny. Again, that idea of reading from top to bottom, I want to read logging before the packet gets dropped. I know the policy would have worked because it matched one endpoint. So the idea of staging is saying in IP tables, I see this rule, it's getting matched. Now, what would have happened in that scenario? So I'm not seeing any allowed or denied traffic. Maybe we need to just wait a few moments, and now you can start seeing allowed traffic coming through. So based on that staged recommended policy, it said, if you enforce this policy, it would definitely have allowed the traffic for logging. And as that traffic starts getting allowed, naturally the default deny won't be denying those packets. So if you left it run for, say, 5-6 minutes, you're pretty confident there's no denied packets, there's no misconfiguration here. You can then kind of upgrade your policy from edit, then from stage to enforce. And just like that, any new packets that go and they hit IP tables, it's going to see that rule and it's either going to allow or deny based on the way it's configured. So now you really have a true zero trust model because you can prove to an auditor no packets are getting denied in this default deny. As I say, you just need to wait a few moments to let Prometheus update those metrics to prove what is currently happening. So these are some old denied packets. In a few moments, that should drop to zero. Now, compliance is met in a bunch of different ways. So we talked about proving to an auditor that you've got compliance in regards to the policy design. Another thing to look at as well is, let's say, if I do what Sergio mentioned a while ago, we were enforcing policy via the CLI, but I may have given this admin full privileges in this environment. So they may have changed by error the IP CIDR range. Maybe they try to match a label, an endpoint selector, and they say network equals public. There's nothing to stop this user right now from applying label matches that don't actually make any sense. Like there is no schema that's called a key pair value match of network equals public. So right now they're making changes that are going to, let's say, not actually allow that ingress traffic. So it's going to cause a problem. Why this is so problematic is it would otherwise go unseen. Changes to policy, are we auditing? Are we keeping a track record of all those changes to policy? So within each policy, within any file, we have a timeline. So you can see at the bottom, the policy was created in Google Cloud. So I'm logged into Google Cloud with an email address called nigel@tigera.io. So that's my LDAP address. But in this web UI, I'm just logged in as a service account, that I created. So it's Nigel. So if I go to kubectl get SA, there's kubectl get SA. You can see that in my cluster, there's a default service account. There's Nigel, and then there's maybe my manager, Sergio. So we are working alongside each other, but we've all got full privileges, and that probably shouldn't happen. So you can see that maybe the change was made in Google Cloud, maybe it was made here locally, but either way, you can go into the change log. You can see, again, Nigel created it on this date and time, and it was later created by, modified by a service account called Nigel. Keep in mind, it wasn't made in the web UI. It was made, or not made in Google Cloud, it was made through the web UI here because they had like full access to this web UI. So you can say the change was update and it was done at this date and time. And you can see again what change they made, and you can always amend it. You can always export the previous manifest and revert back to a change. So there's always a historical record of the YAML manifest before the change existed. So you can always fix it and go to at least show your auditor, I'm keeping a track record of changes made by solicited or unsolicited users. And that brings up a second issue here. We want to limit what the other user could do. So if I log out of this UI, right now I'm not using LDAP, I'm using base64 decoded tokens. I'm not saying it's the most secure way. In fact, it's not secure at all, but it is the default method in Kubernetes. So you can see here how I log in is with this command to get a base64 decoded token. So when I go to my CLI, what I've done is I've given Sergio less permissions. I've given him basically UI user role when we're talking about cluster role bindings or cluster roles. So when Sergio logs in with his base64 decoded token, you'll notice that I treat him as a manager. He should be able to see all the stuff I'm working on, but I don't want him to be able to change policy. I don't want him to be making any changes that will otherwise compromise the cluster. And you can see now he can't modify my policies. He can't do anything. He can open and see what pod matches it based on, again, all that rich context that's in the pod. And you can see he can't even create any tiers or anything that would otherwise compromise my setup. So he is limited to, again, he has full visibility. He can go into the graphs. He can see what's going on. So maybe he does need to audit. Maybe he needs to generate compliance reports and show those to auditors that we are enforcing some kind of zero trust system. And we'll come back to this in a while. But what we want to do is ultimately make sure that some users have limited permissions to this UI and others have full permissions. Like in the case of this Nigel user, he can go in here, generate his token, which again, it's hard to keep track of tokens because there could be lots of them for lots of different users. So the best practice is, like Sergio said earlier, if you want to integrate into an existing ID provider, maybe it's a Azure Active Directory, you can do that so that you're logging in with an email address and everything else that's already, using single sign-on. So now you can see in my access, I can go into policies and make those changes. I can add tiers and so on. So that's it. The RBAC element is really, really critical. But what we were talking about there a while ago is compliance. Let's say I have that network namespace, it's called storefront, and I want to say, generate compliance reports on an hourly basis, quarterly basis, whatever it be, for your auditor to say, for that network namespace, are they protected on an ingress egress level per policy? So right now you can see I have a cluster, I've got 59 workloads, and only 25 of them are secured by policy. And that was the last report, keep in mind. So as I start introducing new workloads, based on however you design this, again, I did this in YAML. So I would say something on the lines of, well, this is a global one. So I said for the whole cluster, but you could say something on the lines of, because again, it's identity aware via labels. You could say for the namespace storefront, anything with the label app equals backend, track those workloads via these automated scheduled reports to say, are they protected on the ingress egress level by policy? And what this allows us to do is you can simply export these reports in CSV, and you have a historical trail to show your auditor. Again, if you're a regulated environment, it's really critical. You don't want to just say on the day, sorry, I don't have no way of proving this to you. You want to be able to show them, look, every day there is a policy or there's a compliance report scheduled that is tracking anything with the label selectors app equals backend and proving that it is secured by policy. How it's secured is not, for us to worry about right now. It's to show them that you have policies in place, that you didn't just make them yesterday, and for the last 6 months, you weren't securing those workloads. So there's compliance reporting as well within the solution. So we talked about, within the policies, creating that zero trust scheme. We talked about, actually proving that you're, prepared for a rogue workload. And I can actually show that right now. Say if I go kubectl apply-f, and I'm pretty sure it's called rogue, or maybe I want to just ls to see if I have that file. And it's probably the point I'm just going to end up on, but where did I have that file? And I'm pretty sure I called it rogue. Oh yeah, storefront demo. No, it wasn't storefront demo. I had a better name for that. And if I don't have it, that's a shame. I can just get it from my GitHub repo, to be honest. But why I want to show you this last one is in the scenario where there's a compromise to your cluster, you want to be prepared for anything that could happen. You know, you want to have this security posture in place. So I could introduce a rogue workload into that network namespace, which we have right now called storefront. As it's introduced, you can see easily that I can now, well, you can actually see the pod. You know that it doesn't have those labels that we talked about. So it didn't match the label schema that would have allowed the traffic, again, in identity aware scenario. Our UI quickly reflects that there's now not 5 endpoints, but it should show, 6 endpoints, including the rogue attacker app. And if we were to go into our visualization, we would be able to prove to an auditor via graphing as well that for the network namespace storefront, and maybe I want to, I'm fine to show that at the moment, there should be now a new spike in traffic coming from attacker app. And you can see it's talking to everything. It's trying to talk to alert managers, talking to compliance, talking to email service, and all of it's red. As we can see from the legend, it means denied. So that's really important. This flow visualizer shows us the volume of traffic. So although at the moment it's small volume, you probably wouldn't be identified easily by a DevOps engineer. We can ensure it by having, default denied to ultimately deny it. We can use our alerting capabilities. So we have activity where we can generate alerts to show, again, you can build your alerts to say, if there's unusual SSH connections established, or if there was unusual port scanning we've seen within a cluster, then it would auto-populate, say, in a certain network namespace, a pod with a certain name is doing something, like it's trying to probe an app in the network namespace or anything with app equals internal app, that would flag an alert. So you can have ways to keep reconnaissance to notify the admin, okay, there's unusual behavior, but more importantly, you can see there's a huge volume in this default deny, dropping those packets that are coming from anything that wasn't in this identity aware system. So that even if it's talking to pods in that namespace or to other network namespaces, it's ultimately isolated. So when you go into, say, that graph and we look at, say, I don't know, the last 5 minutes of data, the most current data, you're going to get this alarming view where you can see something in the network namespace storefront is doing something it shouldn't, and it's getting denied. So you can see it's trying to talk to anything, but because you enforced a zero trust model, all of those packets, no matter which ports and protocols are being used, are getting denied. And you can see originally they show up green. It'll take a while for those to reflect red, but we know for sure they are denied packets because, again, the logs at the bottom are all denied flows going to those different destinations. There's a bunch of things to consider when enforcing compliance. If we were meeting PCI compliance, they may also say you have to adhere to a system hardening best practice. So when we talk about system hardening, or I could just type in hardening, they'll often say you need to meet some benchmarking framework like CIS. We can, like we talked about, leveraging inventory reports. We scheduled those earlier. You can schedule CIS, the Center for Information Security reports. Obviously, CIS are a third party, but they're industry regulated and recognized. So their framework, their best practices, we can get reports for that within our UI. And similarly, they'll request in the likes of PCI, they want IDS, IPS type capabilities. So if I was to go back into my UI, what I can do is I can subscribe to threat feeds. Now I should have an example. I have this Fyodo tracker. So if I was to say VI on Fyodo, what you can do here is you can say, I can make a global threat feed. I can subscribe to IP feeds. Like you can see, it's an IP set. So I'm making a pull request from any HTTP based URL. This is the URL that I'm pulling the data from. So if I try to copy that, you can see Fyodo tracker, this company abuse.ch are updating this feed, again, similar to Symantec or Trend Micro or whoever the security vendor is you're working with. They've updated this on the 7th, which is today. So they're updating it every day. And it's just an IP feed of IPs associated with command and control IPs, essentially block list. And they're updating it every day. So what we can do is we can simply subscribe to that IP feed, then convert it into what we call an object, a global network set with the label of threat feed equals Fyodo. And why that's so critical is that if I said kubectl apply -f fiodo, I don't have to build policy based on IP. I'm still doing it based on label, yet all those IPs are managed by someone third party. So when we go into our UI, we can now go to this object of network set. We can see fiodo tracker. There's the IPs. This is updated every day as they whitelist known good IPs and they blacklist known bad IPs. All I have to worry about is having threat feed equals fiodo, that label. And yeah, I could go into my high level security rule before product and use this concept of shift left to say block bad IPs, something like that. And I can make it a global rule, so it can apply to the whole cluster. And then on ingress and egress, I could just say deny any traffic. I don't see why I should filter it down by protocol. So I can say anything that happens to go to threat feed equals fiodo. That's the feed that I was subscribing to. That was the label injected via that YAML manifest. And I can do the same on my outward egress traffic. Why this is important is you can prove to an auditor that you are now also providing firewall-like capabilities like IDS, IPS, and you're denying traffic to known feeds that are, again, regulated, updated, maintained. It's no good just saying, I had an IP feed from like 6 months ago. You want to have the current thing. So you can just say deny to, again, threat feed equals fiodo. So just like that, I can stage my policy to see what effect it would have. But it applies to all 62 endpoints in my cluster. If any of these pods, like again, that rogue workload, try talking to that those external IPs associated with bad IP lists like command and control servers, then this policy will flag it and deny those packets. So although we're denying it later on via default deny, you can have a shift left and enforce higher level security rules at the earliest stage. So with that, I'm aware of the time I went over a little bit. I hope this demo was really useful, but obviously if any questions come up about it, you can chat with myself or Sergio especially, and we're more than happy to help you with that. Okay.
Thank you, Nigel. Yeah, we're going to leave it here then, and unless any questions you want to ask either of us.